Good day everyone, welcome to the Dynamic Maths channel. Today we'll be solving differentiation. This topic can be hard for some people, but this is what the video is about. Examples shown here are made simple to demonstrate the basic principles of using differentiation. If you're ready, grab a pen and paper and let's get started. Here is the basic differentiation function. We have a basic function y equals a times x to the power of n. Y is just a variable in which it is defined by this function. A is just a constant. X is the unknown variable. And n is the power, a constant power. To differentiate to dy dx, all we need is to bring n to the left side of x, and then we subtract the power by 1, which is given as here. After that, all you have to do is multiply each term and we will get a times n times x to the power of n minus 1. Here are a few examples. We have 3 different questions to solve by using the basic differentiation functions. Let's solve the first question. Y equals 3x squared, and we want to differentiate in respect with x. By following the rules, we bring 2 to the left side of x. We leave 3 times 2 times x, and the power will be 2 minus 1. We will get 6x. In the second question, we have a longer function. We have 4x squared plus 3x plus 10. Let me include that y there. Alright. And dy dx is equals. To differentiate this function, we consider these terms as separate. So we have a, b, c. We can differentiate each one of them and solve the question. By using the same rules, for a we have 4 times 2 times x, and the power is 2 minus 1. Do the same for 3x. You will get 3 times 1 times x to the power of 0. X to the power of 1 minus 1. The reason the power is 1 is because there's a function of x here and it does not have any power number, so it means it is 1. And for the third term, 10, because it does not have x into the term, we can simply substitute it as 0. Now we solve the question. We have 8x plus 3. This is your answer for the differential. For the third question, is similar to the others, except it has letters instead of numbers. Again, we want to differentiate in respect with x. Any terms that does not have x can be removed immediately, like 0. Since C has no x, we can safely assume 0. But M over here has an x. So we have to solve for mx. When we differentiate this term, we will get m. The answer is m. The next differentiation rule is the chain rule. The chain rule has a function u in the equation of y. To solve for dy dx, we need to solve for dy du first. Then multiply the differentiation of du dx. Several examples are given in the next slide. Here are some examples to use chain rule. In the first question, we have y equals 3x squared plus 1 to the power of 3. First, we had to identify the u function. The u function in this case can be this function, u. We set u as 3x squared plus 1. And remember, the chain rule is dy dx equals dy over du times du over dx. So we have a function u here, and we can substitute u into the equation. We will have y equals u cubed. Now we can solve for dy du. dy du is 3u, 3 minus 1 gives you 2. Now we have to find du dx. Du dx is, if you notice, u has a function of x. Then you differentiate this term, and this term will be 0. You will get 6x. To get dy dx, it is simply dy du times du dx, which is 3u squared times 6x. But remember, u is 3x squared plus 1, which gives us 3x squared plus 1 squared times 6x. Simplify the equation, you will get 18x times 3x squared plus 1 to the power of 2. So the answer here is The answer here is 18x 3x squared plus 1 squared. Now we solve for the second question. For the second question, we have y equals 4x squared plus 3x plus 10 to the power 3. We treat this as u. So u equals 4x squared plus 3x plus 10. From here we can solve du dx, the du dx component, which is 8x plus 3. We substitute u into the y equation, we will get u cubed. dy du is 3u squared. Combined together with the chain rule, our dy dx will be 8x plus 3 times 3u squared. And remember, u is also a function of x. We substitute u into the equation, which is 4x squared plus 3x plus 10 squared times 3. Can combine them all together, your answer will be 8x plus 3 4x squared plus 3x plus 10 squared. This is how you use chain rule to solve complicated differentials. The next rule of differentiation is the product rule. Here we have y equals u times v. U is a function of x and v is another function of x. To get dy dx, we have to equate it to u equal u times dv dx plus v times du dx. We have four components, which is u, v, the differential of v in respect to x, and the differential of u in respect to x. Here are a few examples. In this first example, we have y equals 3x squared plus 1 x plus 2. We need to determine u and v. U is this function, v is this function. U equals 3x squared plus 1 and v is x plus 2. Remember, to differentiate this to get dy dx, we need u multiply dv dx plus v multiply du dx. We have u and v, now we need to find dv dx and du dx. Du dx is 6x. dv dx is equals 1. Now we have these four terms, we will solve dy dx. dy dx is simply 3x squared plus 1 and times dv dx, which is 1, plus v, which is x plus 2 times 6x. Simplify the equation, you will get this is the answer for the first part of the question. In the second part of the question, we have y equals 4x minus 3x squared times 3 minus 5x. set our u as 4x minus 3x squared, and our v equals 3 minus 5x. Our du dx will be 4 minus 6x. dv dx on the other hand will be minus 5x. Now we solve for dy dx. 4x minus, wait, let me write the formula first. I'll write the formula over here. dv dx plus v du dx. Right, so our u is 4x minus 3x squared. dv dx is minus 5x plus our v is 3 minus 5x, and our du dx is 4 minus 6x. After that, we try to simplify the equation. You will have minus 20x plus 15x squared, and then we have a quadratic equation here. 12 minus 18x. We multiply 3 into these two terms, and now we multiply 5 into these two terms. X plus 30x squared. So we group all the like terms together. 15 plus 30 gives you 45. Minus 20 minus 18 minus 20 will give you 58. Plus 12. This is the answer for the second question. In the next rule, last but not least, is the quotient rule. In the quotient rule, we have u and b, which are functions of x, as a fraction. We have u on the top and v at the bottom, the numerator and the denominator. To get the differential of dy dx, you have to use this formula to solve the differential. By using the same concept of the product rule, in which we had to find what is v, what is du dx, what is u, and what is dv dx, we can solve the quotient rule. Here are a few examples. In the first question, we have 5x over x cubed minus 2. We have to identify the u and v. We can see that the u is 5x and the v is x cubed minus 2. Let me write down the formula. So dy dx equals v du dx dx. Du dx is simply 5 and dv dx is 3x squared. Hence, your dy dx equals to this formula. So we find the value of v, which is x cubed minus 2. Du dx is 5. U is 5x. dv dx is 3x squared. And v squared is simply x cubed minus 2 squared. Let's plug in those values in this equation. So we put the brackets if you are not sure, and then du dx is 5 minus u is 5x, dv dx is 3x squared. And now it is divided by v squared, which is x cubed minus 2 squared. You can simplify the top, the numerator portion. You will get 5x cubed minus 10 minus 15x cubed which will give you minus 10 x cubed minus 10. You can simplify by factorizing 10. Negative 10, you will get x cubed plus 1 divided by this is the answer for question number 1. Let's try question number 2. I'll put a division here, divide, some sort of a divider to show the difference between the two steps. Here y equals 4 minus 3x divided by x squared plus 3x plus 4. Compare the steps between the first question and the second question. We need to identify what is u and v. As we can see, u is the numerator portion and v is the denominator portion. So let us write. U is 4 minus 3x and v is x squared plus 3x plus 4. Get the derivative for du dx and dv dx. Du dx is minus 3 and dv dx is 2x plus 3. can find our dy dx. Our formula is v du dx minus u dv dx divided by v squared. Same as the first one. We can start by putting the values of v first. And du dx is minus 3 minus u is 4 minus 3x because I don't have space, I'll just write it under here. dv dx is simply 2x plus 3, and we divide this whole thing by v squared. V is x squared plus 3x plus 4 squared. Because the equation is complex at the numerator, I will simplify it as negative 3 x squared plus 3x plus 4 minus 4 minus 3x 2x plus 3 divided by x squared plus 3x plus 4 squared. By right, you should multiply the negative 3 into these terms and expand these two terms and solve all together. But for the sake of time, I will leave it as it is. This is the answer for the second question. In conclusion, we have learned about 4 different functions or rules to solve differential equations. The first is the basic differential function. The second is the chain rule. Third is the product rule. Last but not least, the quotient rule. The basic concept of using these rules is to identify what is the meaning of each symbol. For example, a is the constant, u is the function of x, just as is v. V is also a function of x but of a different form. By understanding these values, we can substitute these values into the equation and solve for the differential equation of y. If you manage to understand these questions, please practice more, and if you still do not understand them, please comment them in the comment section below. This is Abraham's Dynamic Maths channel, signing off.